Uh, Grinding on the debugging of the C++ code. I got the. I stayed up a little bit after I stopped streaming last night, and I got the insert by path working. So now I have kind of a framework for the other ones. Right now I'm working on insert by point in depth. It looks to be mostly working, but the path calculation is incorrect. So I'm trying to figure that out right now. Basically, as soon as that's done, I think it's going to start kind of some dominoes falling into place because insert normalized is just a wrapper function around that. Let's go ahead and see because I'm in the debugging stages of this. So take a look at depth. It's 10. We're not going to enter that. We skip over it. We got octant index to 0. We got a point x. Point x. Our node data is the root right now, I would assume. What's our parent? It's a null pointer. Yeah, so we're on the root. So it makes sense for this calculation. All of these are less than, so we have just a 0 for our first child. That makes sense to me. Let's take a look at his stats at this point. Node data is unset. That happens here. Node data is now set. Seems fine. All right, so at that point, we go ahead and invoke the recursive call. And this is where it gets fishy, I think. All right, what's our depth now? 9. So that seems proper. What are we? What's our parent? And its parent. I mean, that seems correct. So now, what's our center here? All of that seems correct to me. It must be on a 0.5, and that's why we're overlapping here. Okay, so we go into 0 again. We cycle again. Okay, so now we should be at 8. And now we should be... different. So we come down here. Point X now is this number. Is this number. So now we should be greater than. Greater, greater, greater. Does seem to be closing in, does it not? Which is the behavior we would expect. Sort depth that here. Now we're hitting the recursive callbacks. So in a weird way, this makes sense to me. Excuse me? Okay, true. It didn't hit the 0. 1312. 1312 should be false. Yep. Okay, makes sense. And now it's definitely greater. I'm not convinced it's not working here. This may actually be correct, and it's my testing methodology that's flawed, assuming that like 0.5.5 would give me some kind of meaningful results instead of like always the same numbers everywhere. I really need to probably be injecting random numbers into it. This is different. This is different. This is different. And this is different. They're all different. There's something funky going on here where they're randomizing to the same values, so I may need like a break or some kind of delay or something like that. Oh, no wonder. It's because they're seed 777 because they all end with, okay, I know what's going on. So it makes sense that they would all randomize the same shit because they all have the same seed. And if it didn't do that, we would be a little bit worried. So let's see. Open the level blueprint. Yo, what up, dude? What's going on? So yeah, my testing's flawed here. I need to be testing the axes. So like instead of doing something like this. All right. I love rubber ducks. I'm just debugging, or actually, I'm not even sure if I'm debugging. The function may be working. I'm trying to test some Proctree functions I've written in C++ before I set about making them asynchronous. So I'm basically here to beat it up, test everything, and debug all the stuff that's wrong with it. So that's what I'm working on. In particular, we're looking at the insert node by point and depth functions. Let's take a look at these. The 7s are probably due to me using like even numbers, basically. Even. It's like pulling it back after it overshoots it, maybe. Or it could just be fucking wrong. That's possible too. All right. What if instead of doing it like this, we do it like this? Let's try it with some random vectors. I don't know, man. I think that looks pretty good to me. I think I was just biasing it by attempting to use numbers like 0.5 in a system that's a power of 2 system. So, like, it makes sense now that I'm thinking about it. Like, if I'm going to find a test number and that's guaranteed to produce patterns in the data of a system where every node is times 2 of the children node and half of the parent node, then using 0.5 as my test value probably would be a good way to do it, huh? So this seems to work. That's big. Let's see if the the actual math here makes sense. So we started at the root and we inserted a series of points decomposed at depth 10. These are the indexes they fell in their parent. These are the actual path that was generated in the Proctree. These are their center coordinates, sizes. So the first and easiest thing to check is the size versus the size. So this size should be log 2 of this. So let's try it. log 210. How do I do that on this fucking calculator? Log 2 in. So it would be this number as the root size, log 10. No. Fuck. Log. No. I don't know how to use the log function in this fucking calculator. Not a math major. Maybe coworker can help us with that. Do you think it'll get the math right? It often doesn't. I don't know, man. I haven't been using Bing, but if it's hooked into the same shit, maybe not. I hope OpenAI is getting paid from Microsoft because I haven't used the Bing chat, but I might try it. No, I think I did this wrong. I'm just saying, like, the only reason to subscribe right now is GPT-4, and if Bing has opened up GPT-4 to just general use, then... Yeah, I actually watched a video earlier today, and the guy made a really good point that, like, all this generative code shit is great, but what would be really amazing would be for it to find bugs or logical flaws in already existing code that's not like a actual like technical error in the application, but could be like a bad optimization point or something that could cause like a race condition or something that could cause like a Heisenbug somewhere. And I thought that was a really good point. Like that would be really nice to just feed it into logic itself being flawed, even if it might work. Yeah, exactly. Like you got to be careful with the stuff that it tells you to do. You take everything it says with a grain of salt, as if it was like it's really good. It's an amazing productivity tool, but you have to understand what you're doing, or I think it's a trap. Okay, so I think it seems I've insert by point. Oh man, that means I get to set up. Soon I'll be debarking on the multi-threading all this. I'm using Copilot right now. It's complicated. It's complicated. I think it's useful. It has the same caveats that come along with ChatGPT. You need to review everything it does incredibly carefully. It gets things wrong probably more often than it gets them right. But that doesn't mean it's not useful. Because I've also seen it spit out entire blocks of like very graceful solutions to something that I would like, something done on like one line that I was about to do in like a whole function, and it's like, oh, yeah, I guess I could do it that way. That's nice. So like it depends on how valuable to you the 20% of the time it spits out something that's like actually really cool is, versus the overhead of having to disregard what it says like 80% of the time. It's really good for boilerplate for sure. I don't mind. No, not really. You have to like I've been doing C++ now about 2 months. I did some C a long time ago. It's helped me jumpstart my understanding of the syntax. Um, but I also understand that like I have to like vet everything it says, and I'm at a point where like it could feed me C++, and even if I don't know the language, if I'm looking at the code, I can usually figure out what it's doing, and that's a big help, because otherwise I would be spending a lot of time researching like syntax and just how to like do very basic shit when I really want to do more complicated shit. It's good for that, but you have to be aware of like the pitfalls currently involved in using it. It's not amazing at Unreal syntax. It's not amazing at C++ for that matter. But it does occasionally lead to some graceful solutions and like pretty good solutions. So it's like, is it worth it to have this kind of semi-distracting gray text that is wrong a lot of the times for the opportunity for like maybe every now and then it'll just bam spit you out like something that's like absolutely perfect, and you're like, oh damn, that's cool, you know? It's like the noise to signal ratio is high, but some of the output, some of the signals that you get are like keepers, basically. I really do. Like honestly, a big part of my difficult, like I've been grinding on trying to get this working. Like I got it compiling the end of last week, and I've been working on getting it like actually functioning. And now it looks like some of my inserts are actually working correctly, but it's been a trial because I want this whole thing to be thread safe, and there's a bunch of kind of extra conceits I have to take in the design here because I want to multi-thread it, and I can't use recursive U objects because it's not thread safe to do that. So what I have to basically do is create the data model in C++ types that are not U objects, form a U object wrapper adapter layer around those kind of core objects, and then put all the logic for modifying the object itself inside the core so that I can hand it off to a second thread and have it just modify itself. So all that requires like locking, proper locking. I'm using reader-writer locks. It requires kind of the understanding that like, oh, I need a workaround for like off-thread data generation. And so I've been working on that. I haven't got any multi-threaded stuff in here yet, but the locks are in, so I'm testing the methods all synchronously first, and then I'm going to multi-thread it. But yeah, it's a big part of the challenge was the fact that I started out with Unreal Engine types, and they weren't working right. So I tried swapping to C++ native types, and they weren't working right. So then I started looking into, and then I finally landed on some like Unreal Engine types that are not like UObject types. Like I'm using a bunch of smart pointers right now, and weak pointers, and shared pointers that are like Unreal Engine managed pointers. And that was like the sweet spot because like it was easier than having to manage all the pointers myself, but still good enough to do what I needed it to do. And that's when everything started clicking into place, was when I realized that like, okay, I can still use the T-array. It makes everything simpler to use it. I can still use the shared pointer types from Unreal. I just can't make any recursive U objects off the game thread. And then like everything started working when I started doing it that way. So I had to go refactor every fucking thing, which I did last night. And like all of this is just like progressively overcoming different setbacks and like, because it's difficult to grab something complicated and then go try to do it in a language you're not familiar with, you know? Well, I've been a software dev for 14 years, so I just have only been doing C++ for 2 months. And I've been doing Unreal for longer than that. Like, I made all this stuff in Blueprint multiple times before I attempted to do it in C++. And the reason I'm doing it, like I said, is that my Blueprint implementation is making U objects off the game thread, which is not safe, so it crashes sometimes. Um, but yeah, I'm able to draw on my experience in a lot of different languages, and like everything kind of blends together. Although C++ does have like a bunch of hurdles to jump through that something like C# or Java you don't have to deal with. And but like I said, I've also done one of my projects that I did right after college was like an AI project. I wrote a little neural net from scratch with a genetic algorithm, like adversarial training strategy, unsupervised. And I wanted to be able to spend generations on that genetic algorithm on a graphics card because it benefits greatly from being massively multi-threaded. And at the time, you could use CUDA, um, or you could use OpenCL. And I opted at that time for OpenCL, but that required you to write a basically C kernel in a text file that you would push to the graphics card alongside with pushing all your memory, all your data for that shit in that you were going to need to iterate on into the graphics card's registers, and then you would go iterate on everything in your actual like text file C kernel that you push to the graphics card, and then you had to deallocate everything and like everything just super pain in the ass. And that was a pretty reasonably complicated algorithm. So I'm not like clueless when it comes to C++. I knew that it was going to be like a pain in the ass in certain ways. So I kind of had the benefit of expecting it, seeing it coming a little bit. Okay, so back to code. So next, I think I have to test my getters. If my getters work, just looking at what they're doing right now. So any recursive calls, I can't lock inside the recursive calls. I already learned my lesson on that because I deadlocked it earlier on in a call that I realized was recursing. So it was like the call was generating a writer lock, then calling itself, which is a deadlock. So anything like that, I have to move the lock out side of the recursive call. So I may need additional wrappers around some of these classes to ensure proper thread locking. Something that I'm thinking about right now, or just ensuring that I interact with them in a intelligent way elsewhere. This might also have to be a pointer. Yeah, the 2 months really kills you on things that are not necessarily like logical or understanding like the way to build the flow of like the components or the underlying mathematics of the octree or things like that. You have a good grasp on all that shit. I wouldn't have even attempted this if I like until I did. Um, but it's struggling with things like, oh, I was passing around pointers like this for my internal C++ object, and it was actually just leading to a huge clusterfuck and null pointers and dereferencing issues and all that shit, which is when I changed to shared wrappers for or shared pointers for those things. And like just the overhead of fucking up little shit like that you just don't know because it's an idiosyncrasy of the language is a lot. And that's been my biggest struggle. Or like for a while, I didn't realize that if I wanted to delete files, delete like a class, like I can't just do that. I have to jump through some hoops, or it's gonna literally fuck up the whole project. Um, so like I bricked one plugin that I started working on that way, and I just like deleted several files, and I was like, well, this is just fucked up beyond the point of I just might as well just restart it at this point. And then I deleted one in this project at one point, but I had already coded a lot of shit, and so I had to go figure out how to actually like properly recover from that instead of just being like, okay, we'll just abandon it, you know, abandon ship, abandon ship. So like my biggest problems end up not necessarily being that like I know what it's supposed to do. It's the translation layer between that and like how do I do that with taking into account all of C++'s many decades of idiosyncrasies and differences for with like higher order programming languages that I work in on like at my day job, you know. It's a different mode of thought. You have to take more into account. So I'm trying to think of where I go. I mean, I'm inserting nodes by path. I'm inserting node by random unit vector points at a given decomposition depth. I guess I could try boosting the depth and start pushing the recursion limits a little bit higher. It's fun, dude. I like this shit's like Legos for me, dude. It's like the biggest, fanciest, most complicated and hard to understand Legos. You like, do you want to code? Do you want to do like visual shit? What are you trying to like start with? Because I've been on the same path as you. I started learning Unreal when 5 dropped, so not even a year, I think, unless I've lost track of time again. And there's a lot of cool shit to go into. Like the materials are really fun to fuck around with. The particle systems are cool. Volumetrics are cool. The Proctree stuff is cool. The geometry scripts are cool. Um, and then you got C++, which is obviously cool because C++ can do whatever the fuck you wanted to do, but it's also very intimidating. Sure. I've actually, I was hoping to get, I was hoping to get fucking further along on here on the test harness for this, but I've spent so much time this weekend to get into. I wanted to do some parallax occlusion mapping textures because I've been looking at some render bucket videos that were really good on it. But this has just been like a struggle just to get it to compile first of all, and then to get it to actually insert the nodes, which it seems like it's doing now. I want to see what happens when I insert some at depth 20. Longer path. What about a relative size? Relative size is smaller. So I don't know if you understand or are familiar with an octree. An octree is. Why don't I just show you? I'll show you. It's cool. This is a plugin project. This project is really just for me authoring this plugin. This plugin I will use in another project that I'm currently using a blueprint implementation for. And it's a universe sim kind of like, or like the idea is to create a harness to where I could start plugging away, making a universe sim akin to something like Space Engine. So to do that, you could use a data structure called an octree. If you imagine a cube that occupies some region of 3D space, and then you subdivided that cube in half along all axes, you would have 8 smaller cubes. And that is basically the concept of an octree. It's a tree where your position in the tree stores relativistic information about your size and location in space. So normally, you would use an octree to decompose potentially pre-existing points in your scene, things that you've already generated. But this project is using one to, yeah, and speed of lookup, and it gives you like nearest neighbor, efficient nearest neighbor search, and things like that. So this project is intending to use a octree to generate procedural data that I can hook into rather than decomposing existing data. So I take a few caveats. The tree, normally you wouldn't have a node size of your leaf defined, but I define it at 2. That puts all the values in the whole number range. And the idea is that you can use it to conceptually represent different objects at vastly varying scales. So it's powers of 2. So if your leaf size is 2, then the next node up from that size would be 4, and the next node up from that size would be 8, etc. As many levels as you go deep. And that means that if I insert some nodes at a given depth in the tree with a relative scale to the node that they're in, then they will be automatically scaled differently depending on how deep I insert them in the tree, and they'll automatically be centered on a different point depending on where I insert them into the tree. So the idea here is I could insert, say, a bunch of galactic clusters at depth 5 in the tree, like very high up towards the top of the tree. And then I could, under those, generate a point cloud and say, insert these points as galaxies within your relative frame at depth 10. And those would get decomposed into a point cloud at that depth. And so the galaxies would be 10 powers of 2 smaller than the galactic cluster. And then I could pick one of those galaxies and I could say, okay, I want you to generate all your stellar clusters 10 levels down as well. Same thing. So now you have a stellar cluster. So let's just see it. Okay, we got our galactic clusters. And we got our one galactic cluster that we actually populated off in the distance. So we're going to work to that. And you can already kind of see the flickering here. Oh, I'm a little off target here. I think I'm not at the 0 origin here. Okay, so now at these relativistic scales, I have different things, right? And these scales are like really, really, really fucking big. And like, it'll stop after this one. This was like intended to test like spawning in a second system and warping from the first system, basically. So the cool thing about this is you can use whatever kind of point cloud function you want. So here I just have a point cloud function I wrote that does globular point clouds. But here I've got a point cloud function that does spiral point clouds, right? And none of this is textured. These are just the colors of basically the voxel cores of the points. So the voxel cores store your unique data, right? So I have a move speed right now of the maximum camera speed times int 32 max to be moving around at this at even a usable speed in this, right? And you notice that when I move, the red points almost don't move at all, even though I'm going as fast as I can actually set it to go in the editor, right? So that's an idea of the scale we're dealing with here, and why, if I wanted to, say, have the user only be able to travel in the galaxy, right? I don't want you to travel between galaxies by just flying there. Well, if I take this down to a more reasonable number, say like 40 million, okay, that's still too fast. I also have this, the octree's a little bit smaller than it can be right now because it's just not practical to have it be larger. But let's go an order of magnitude slower. Maybe even a little bit. We'll go a quarter of that. All right, so if I set the user's max speed here, I could have them able to transit between stellar clusters in a galaxy. But they ain't never going to get to another one of these galaxies unless they're sitting Well, you actually don't even have to do that. Everything is like actual universal scale, so they're just straight up limited by the speed you allow them to travel at. Like that's kind of what I'm getting at here is like you could you could go around and visit points inside this galaxy, but if I wanted to get to another one of these pink points that are representing other galaxies, it's at the speed I'm going, you just yes, exactly, exactly. So it's just like it works just like the real world. You see what I'm saying? Like we're not restricted by like some arbitrary boundary around the Earth from going anywhere. It's just that we can't fucking do it because it's all too fucking far away, right? So like if I go to the last one, this would be like a star system or like a single stellar cluster inside the galaxy. And now I'm moving at like interstellar speeds, right? But again, if we wanted them to move at like interplanetary speeds, I could just say, okay, well, we're going to define one unit as 1 kilometer, and we're going to say you can go 100 kilometers a second. And this is how fast you can go between stars. And now it's like you can't move around in the overall galaxy, and you can see all the nested structures you're in contributing to your actual skybox of what you see in your night sky, right? Like, and don't expect like these them to just be blobs. You could have different textures on all this stuff. You could enter like some of these blobs could correspond to nebulas. Some of them could correspond to star fields. Some of them could correspond to black holes. All kinds of shit, right? Like whatever you want to put in it. Um, and so like now we can just barely creep along at like interstellar travel speeds where it would probably take you like 10 minutes to get from from a system to a system, but you can't move around inside the galaxy even though you can see its contribution to your night sky along with the cluster you're in's contribution, etc., etc. So underlying all this stuff is this structure called an octree and the ability to generate data into it performantly. um, the data structure is what I'm working on right now in C++. That's what I'm testing. The ability to insert stuff into it requires it to be effectively multi-threaded because you don't want to run any of this, any of your point cloud generation code where you're generating point clouds of like 10,000, 20,000, 50,000 points. Any of your bulk insert into the tree code can't be on the game thread because all of that shit's really expensive. And also your nearest neighbor search and like your layer scans and things like that to find the things that are directly around you are also expensive. So the goal of kind of what I'm doing right now is to kind of finally get rid of my fly-by-night blueprint implementation of all this shit and actually have it properly locked, properly multi-threaded, as optimized as possible, so that I can continue to go forward with actually populating all this stuff with cool shit. Because before I want to do any of that, I want to be sure that like the underlying structure that's going to underpin everything is like rock solid. You know what I'm saying? Even if I do everything else in Blueprint. Although I'm probably going to at least write a 64-bit PRNG in C++ as well. But that'll be easy compared to what I'm doing right now. Like, trivial. But yeah, so like even though I can see that this off in the distance, I can't actually get there unless I just like double click it and have it kind of alert me over here. There's some other stuff involved here. You don't the distances are so huge that you actually don't let the user travel. When the user can travel in their local coordinate space, but when you warp between coordinate spaces, I'm actually moving the whole system because that way the active system can always be at 000 inside the large world coordinate space, and then you get like a few billion kilometers of precision, and that's usually going to be good enough for whatever you're doing. But like if you actually travel out here without moving it, everything jitters around and shit because it's all like running into floating point errors and stuff. It doesn't matter for far off stuff because it's so fucking big that the minor precision errors are not a big deal for like the positioning of like the big stuff. But the small stuff, see if I can get it to do it. Yeah, you see it, but you see it bouncing around. And that's because I'm far from the origin right now, because when I warp to that other point, I also moved this whole system at an offset to put this at 0, 0 so that I can move smoothly in it without it jumping around and shit. And my axes are flipped on my mouse, so it's fucking with me. Well, I'm kind of like I look at what other people have done, and I know that Space Engine did something similar to this where they were able to do like seamless intergalactic scale transit with no load screens. And so I started looking in how they were doing it, and they were talking about these things called octrees. I had no idea what that was at that point in time, so I had to go figure out all that shit. And then I made that in blueprints like 5 times, like iteratively. And now I understand it like the back of my hand. It's like, oh, okay, I instinctively get it. But it took me rebuilding it multiple times to finally hit a point where I'm like, okay, I can't go any further on this with Blueprint. I have to go to C++. And then I started picking up C++. And that's where we're at right now. Is me on the starting stages. I actually have an account. I play sometimes, but not usually. So their stuff is partial procedural. I think some of their planet tech and stuff, like they're definitely not making the whole planets by hand, but like it's a little bit more handcrafted approach than I'm going for. Yeah, that's the way. Because I think that that's one of those games is like there's potential there for it to be an insanely amazing game, but it's like who knows when that potential would be realized, you know? If they ever do realize the potential there, then it'll be really cool. As it stands, it's kind of a diversion for maybe a month when they do a reset sometimes, if the patch is good enough. I know. And their skybox still looks like shit. No, I'm just fucking around. I do think that like they would benefit from just like a better HDRI skybox though. I think it's kind of bland, at least in Stanton and the. But yeah, there's also like I haven't only done this stuff either because I'm also interested in like materials and stuff like that. Like I got, yeah, that's fine. I got this stage. I was working on some procedural skybox textures, so this is kind of neat. I made this material, and it has a bunch of parameters here that can just be pretty much randomized. So we can bring the cloud down, right? Yeah, exactly. Yeah, I normally would game a lot. I kind of tend to obsessively toss myself into stuff though. So over the past probably 6 to 9 months, I've been doing way more Unreal shit than gaming shit. But like I said, for someone like me that really likes all this shit, this is like the biggest, coolest set of Legos to play with. But yeah, so we can change color balance of the colors that compose the nebula, uh, distortion levels of the clouds at different tiers, basically, edge fall off of the nebulas, brightness, basically. If you randomize these values, you just get completely different nebulas, basically. And so you can use this to generate like randomized skyboxes, basically. And then if I wanted to keep this. I can just grab this capture cube. This is like not even the way that I would do it, but like, here we go. And now we have it as a HDRI background skybox without them rendered, right? So I kind of run two parallel efforts. One is like a No Man's Sky style where you just generate a solar system. That's what these materials are a part of. And the other is the Proctree shit. That is obviously a little bit more complicated. I also have, you know, like color controls. Oh, am I on the wrong one? Shit. Oh. I'm a doofus. There it is. Yeah, so like I thought this stuff was cool. I'm using some AK noise textures that I've made in GIMP. You can see them actually here. I can actually swap them out if I want. Yeah, so like we can do whatever we want with these kind of. And they'll stay like for the most part looking good as long as we stay within certain bounds when we randomize the stuff. It's like a fucking, like I said, man, it's like programmer Legos. If you like spatial math and you like digital art and you like shaders and materials and figuring out how all that shit works, because this is all just on the materials here, which is cool. It's a lot of fun. But yeah, you can do all kinds of cool stuff with this. It's neat. And once you have a look you like, you just... Oh, look, it's a different one, right? And if I randomize these numbers, it'll be different every time. Like if I randomize all of them. And then you randomize your colors from like palette subselections and things like that so that you don't get... Because you could probably make some pretty ugly shit with this if you had no regard for like the colors you were putting together. Like let's say I did... I mean, actually, yeah, it doesn't look terrible. Maybe not. Maybe it's not as bad as I thought. Anyway. Oh, that was a nice break from grinding my face on code, but I think I'm going to go back to actually debugging this shit. So I need to do... So is my contention that single inserts will not need to be locked. because they're going to be, we're really not going to do any single inserts. Instead, we'll walk the whole process of doing the multi-insert. Yeah, okay, it's not here. Great. Insert by path can be locked because it's not recursive. Like here, neither of these need to be locked, but this should be locked. See? Okay, that was Copilot right there that did that. And this is just boilerplate shit that it will probably get right. I go up here, I check how I did it up here. Looks good. Okay, we're locked. We should be. Return nodes. So this is our bulk insert function. I guess I could test this too, right? Before I move on to testing my getters, my finders. Instead, I shall test bulk insert. So to do that, need the engine running. Okay. Now, this is all overkill. This one does a pretty good test. It's decent. It's actually a shitty test, but it's good enough for what I need to verify at the moment. Let's see. So next, this would be random unit vector. This is okay. think that's it. So let's try a bulk insert here. That's wrong. That was wrong. Why is there only 1 point? Yep, that'll do it. That's what I thought it would be. Here we go. Oh, here we go. 101 points. Sounds good to me. Yeah, fail. Stop. Okay. I think this is wrong. We'll see. Seems like this is probably wrong. It's a T array. It's probably like size or length or some shit. Seems okay. It's got to be defined, I think. What did we get out of it? I mean, I got a bunch, so... The fuck? Oh, oh my god, I'm a freaking dingus. Holy shit. Oops, I thought it was the other one where I have like a checkbox to automatically print it. Fuck me. It's working. Calling it. Yeah. All good, dude. Yeah, this ain't right. It's the same core, is what it looks like. Something going on with the... Something going on with the points themselves, so we need to see them as well. Is my suspicion. Alright. Let's see. Let's see what happens here. Okay, these values seem okay. These are not right, though, I don't think. Yeah, something's definitely up here. Well, I guess maybe not.
Take it and use it in your tangent map for directionality of these anisotropic highlights. There is a way you can do that. So if you take your black and white texture, you create a sine node, you create a cosine node, you take both these nodes like this, and you actually add them
Yeah,
to
that
one
ain't right.
another. So you're going to append many, and you're going to append the sine node into red channel and the cosine node into the green channel. And then to be safe, we'll take the RGB out, we'll normalize this, B channel will just be empty, no values. This will give us something like this, which isn't perfect. And you can see the problem with having textures. This is a low res texture, not very many pixels, 256 pixels by 256 pixels, and low bit depth, and you start to get this artifacting because it's way, way too zero to low. Nothing beyond that, and it's just going to be worse compression and saturation. So it's not the most efficient, but if you can make this it gives us that effect, which is pretty cool. If we tried this using a black and white texture map, that's not going to work. When we do this, sine, cosine, append them together, normalize, now we get something that kind of works. And then if we were to use a texture coordinates node to just tile this,
Well,
we could
actually,
tile
wait a
this like
second.
4 times just to see how it looks. Hey, there we go. We kind of recreated that same effect. So it's not perfect. There are other ways of doing this, but it's going to be the easiest way to kind of make this work if you are stuck with a black and white map. And you can also use it for other things as well, like if you use like a diamond gradient or something, something as simple as this. You add that in, sine, cosine, you can see the result that it produces. So we put that in here, and then we normalize that. Now we have these anisotropic highlights following that kind of diamond texture. So you can kind of really play around with this and get some interesting patterns going. But hopefully it gives you a bit better understanding of how to use this tangent input now. And at least I'll make simple objects like pots, pans, machined, brushed metal a lot easier to produce. If you enjoyed this video or learned something new, make sure to like, subscribe, press the bell notification button to be notified of future videos. And if you are part of the Patreon, you'll get access to the PDF for this video that will go over some things that we went over in a bit more detail, and I'll have some other tips as well. And if you're not part of Patreon, check it out in the description below. And don't forget to leave a message in the comments below if this helped you out, if you made something really cool with it, or what other
Oh,
videos and content you would like to see.
I think I know why. So, these are normalized. That means I need to be invoking this. As it stands, I was introducing. They were all clustered in a tiny little spot around the very center, between -1 and 1, and that means that like after a couple layers up, it's basically always gonna be, yeah. That's it. Okay, so stop. I think that's probably it. I didn't denormalize the point. If that's even the right terminology for it.
dfs are, what signed distance fields or functions are, and then again, they're really just a math equation that describes a 3D shape, and we can draw this shape based on the camera angle using a method called ray marching. So let's take a look at how we can create our very first ray marcher in Unreal. So to begin creating a ray marcher in Unreal, we're first going to look at what we're going to draw with the ray marcher. So we want to draw a 3D sphere in this case. And I'm just going to open up Visual Studio Code so we can take a look at the different code that we do to draw a 2D circle and a 3D sphere. And it is very simple. So like a 2D circle, we would end up just doing something like length and then position minus UV. That will give us a essentially just plotted 2D circle with a gradient. So you'd have your center point, and it would fall off from that center point as a gradient outwards, and draw ourselves a circle and a fall off. And if we want to specify a size, we could do other things like, if it's less than a certain size, then we'll just ignore those pixels or draw them. And there's things we can do to start, changing how that circle's sharpness of the edges are and stuff like that. But that's essentially how we draw a 2D circle. Now, how would we do a sign distance field or a sign distance function to draw a 3D sphere? It's really not that much different. To do a 3D sphere, it would really be the same thing. We do length, but instead of position, we do something called ray origin, which is the starting point of the ray 3D space. And the ray origin is pretty much going to be our camera vector minus the world position, and that's going to give us the starting point of the ray to draw this sign distance function or field correctly. So we'll go into that a bit more, but essentially position gets replaced with ray origin, the position of the starting point of the ray 3D space, and instead of UV, we just minus sphere center. So in the UV case, it's the UV coordinates, whereas here we minus the sphere center, where in 3D space is that sphere being drawn. So that's going to be essentially the same. It's not much different. And then finally, for the sphere radius, we'll just do minus sphere radius. So it's a little bit
I got it
different,
a lot. Yeah. Yep.
pretty much
Dirt-a-roni. So
different
this
functions, different shapes. But
can
for
be
now, we're just gonna
unlocked.
start
If we
with the
need
sphere
if we need
and
thread
have
safe, we can add
sign
wrappers.
distance field or function to draw this.
This
We're going
needs to be
to
locked.
draw
So
it
let's
by
try
using
that.
ray marching. So that's going to be the next step, but really it's not that much different. So same idea, it's just starting to get a little bit more complicated since we're moving from 2D space into 3D space, and it's all going to be just plotted points relative to the camera by using ray marching, but it's really not that much different, and hopefully after the next few steps you'll see that it doesn't have to be that complicated. So the next thing we're going to do is actually start writing our ray marcher.
Bam.
Now that we know how to create a 3D sphere using a sign distance function or field.
Problems are solved. Functions work. Input data was flawed, or actually input method being called was flawed.
The origin of the ray start. And to do that, we're going to define a flow3, and it's going to be ray origin, and we'll make it equal our view direction, which will
Pretty
end
cool.
up having a variable in Unreal called view direction that connects to our camera vector, and we're going to minus the world position or absolute world position in Unreal from that camera vector, and that's going to give us a ray origin. The next thing we're going to do is define a ray step variable, and this will be view direction again, so our camera vector just multiplied by 1, which is just good practice to make sure you typecast it into a unit. And then we're going to do a for loop. So our for loop is going to be what steps through all these kind of positions and draws our actual shape. So you have to define a number of, I guess you could call it samples or loops. So it could be like 128, or in this case we'll do 256. If you do too low of a number, your shape won't draw fully. It'll look kind of wrong, or kind of maybe clip away or disappear, or feel like it's tons of little slices, or it won't look as good. So you want to have enough
All right, so that's all the insert methods, at least the current ones.
Now, if we're not within that, otherwise everything else will just add like a step to the ray. So we'll do ray origin after this. Even if it was within that distance, at the very end here, we're going to add a step to the ray origin. So we'll do ray origin plus equals step. So plus equals adds on this value to whatever value ray origin is. So let's just think about this for a second. Ray origin is our starting point of the ray essentially. And what we're doing is we're doing a loop 256 times. We're checking whether we're within the distance of that sphere that we're defined by our sign distance field or sign distance function here. And if we're within that sphere, the distance is close enough and we're within it, we draw the pixel as red, and then we add a step to our ray origin. So our ray origin increases and it does it again. So it steps through pretty much the whole object, or it steps through this many times when it ray marches that shape, and it checks each time whether we're in that shape or not. If we are, it draws the pixel as red, otherwise we'll draw the pixel as black or like empty. So we'll do return float 3, 0, 0, 0 for red, green, and blue. If we're outside the sign distance field or function. So you can technically look at it like this way. Everything gets drawn as black or empty. But if we're within the distance or within the position in 3D space of our sign distance field or function, then we draw the pixel red. And it loops through 256 times, each time adding our ray step onto our ray origin, and our ray step is just the camera vector
That's cool.
times 1. That's pretty
Okay, so those are done. Now we need to test
the shape will look. Let's flicker
these.
to a few steps and be able to draw it in enough detail, or we'll have kind of little glitches where it disappears from certain angles or doesn't draw properly. So this is our code. This is ray marching. This is ray marching our sign distance field. Quite easy. It's nothing crazy. 16 lines of code. And if we take all this and we put this into Unreal, so I'm just going to go here, create new material, call it ray marcher, create a custom node. We will change a custom node. Let's call it ray marcher. That's it. We'll connect it up to Remissa for now, and I'll paste in the code. There it is. We'll add our inputs and outputs because it's going to give us a bunch of errors. It doesn't know what view direction is or world position, so we need to add all those inputs. So let's start off. We're going to add our world position. We're going to add, what else do we need? View direction. We're going to add our sphere center.
All right, so next test
So those are all the
actually fits well into this one.
referred to that we haven't defined. So there we go. Now we need to connect these up. So world position goes to absolute world position. There we go, world position. World position node is absolute world position. View direction will just be camera vector world space. And then sphere center, we'll just put it 0, 0, 0. Constant free vector. And sphere radius, we'll just put a single value into it, and it will be maybe something like 50. And there we go. We we have this big problem where we still see the shape. If I apply this material to a cube, I still see the cube as being black or dark because it's drawing those pixels as dark. Just like when we looked at in the code, if it's not red, if we're not within the bounds of that sphere, we're returning a black pixel here. So what we maybe want now is a way of cutting away those areas that we don't see. So how can we fix that? We can do that by outputting another variable for opacity, just like we looked at in the last video. So that's something we'll have to do. But before doing that, there's one big problem with this right now, and you won't see this issue until you apply this material to an object in your scene. So if I go back into Unreal here and I just create something like a cube, there we go, and I apply this material, hey, where's the sphere? Now if I reset this cube,
it's based on world position right now.
World space, and
Yeah.
Z, there's our sphere. But if I start to move this cube, it cuts off our sphere. So the problem is our sphere is drawn in world space. And let me show you an example of this. If I scale this up and I go inside our code here, and for our sphere center, I draw it maybe 1 on the z-axis. Actually, we don't even need to look at that. We can just look here. Look at that sphere. Maybe 2 on z-axis. 5, 10. Is it moving? Let's see. Try 100. There we go. It moved. Moved down. So this is controlling its position in world space, but that's a problem because we don't want to have to define our object in world space. Then if we want to move this, it cuts off our object and we have to calculate wherever that new position is. That's too much work. It should always stay in the center of whatever object we assign it to. So how can we make that modification? How can we make it so that this shape or our side distance field automatically moves to wherever our object is translated or placed? And this is really easy to do. Instead of making our world position just equal our world position, we're going to do our world position
Minus our actor position.
subtract our object position.
Mm-hmm.
And by doing that and using that as our world position now, nothing changes here. Everything looks the same. But when I save that now, by taking our world position and subtracting our object position, now it won't matter. I can move this object wherever I want, and that circle or that side distance field or function that we're drawing stays within this object. So that's kind of something we're going to want to modify. So that was really easy to do. And now what we want to do is clip away that dark area. So what we're going to do instead is add an output to our ray marcher. So we'll go down here and add an additional output. That output is going to be called opacity mask. We're going to change our material
That shit's
type
cool.
to be not opaque, but to be masked. So we get the opacity mask connection here. We can connect it up, but it's not going to be able to output anything, so it just disappears. So we have to modify our code. We're going to modify our code here to be a little bit different, where we're going to use that opacity mask variable. We're going to say opacity mask equals 1. So solid if we're within the SDF. And we can actually just put this here, and that should be fine. really help this look better, what would really take this to the next level would be to add some shading on it. It would be nice to get some shadowing on it, some highlights on it. So that's going to be the next thing that we're going to take a look at. How can we write in our HLSL code a way
It
to
just
calculate
fucking
light
works.
position or light direction and using
Sick.
that to do some
That's
shading or shadowing on this
find methods just work.
sphere.
That's
And again,
fun.
this isn't geometry. It's really just points being plotted. Or not even points, that's a bad term. Pixels being plotted based on our camera position. So it's really just pixels being calculated whenever the camera moves to draw this shape. If I look at the wireframe, there's no actual geometry there. It's just a cube. But it is drawing this sphere based on the math from the camera angle and using ray marching to pretty much step through all the positioning of that shape and draw these pixels. So that's kind of the easiest way I can really explain it. But now we're able to draw our sight distance field, and the next thing we're going to take a look at is adding shape to this. So if you learned something new in this video and you found it useful, please like, please subscribe, press the bell notification button to be notified about new videos. And if you are part of the Patreon, which has a link down below in the description, you'll also receive the access to get this PDF that goes over what we kind of talked about in this video in a little bit more detail, and just works as a good reference point for if you're having to do this and you forget some of the steps and you don't want to rewatch the video again. So if you're part of the Patreon, go check that out and download
That
it.
seems off.
And I'll see everyone again in the next video.
Shouldn't this have captured most of the higher order nodes? And maybe erasing activated nodes is now what I'm suspicious of. So we should be able to test that pretty easily because it's all random. So we should get different amounts of squanched nodes. No, that was the same. Still the same. Never mind. Wait. The root? $11 nodes. 101 nodes. It's correct. If I were to do this, it would double. God damn, I can't believe I got this shit right on the first try, dude. Almost every other method has taken a lot of hammering on to get working, but it looks like every method is working now. So that's nice. That means async stuff will come soon. Well, shit. I might do some materials or something then. This is good progress. Do the whole thing. Yep, got the 3 additional nodes. This searched 30 levels of an Octree very quickly. Now, granted, there's only 100 members in there, but even so, that's pretty good. All right. So I may actually take a little break then, since I got this working, and then maybe come back tonight and run through some of these virtual. Oh, shit, what was it? Parallax occlusion mapping. Oh, and I figured out, like, I understand the whole modeling windows and buildings now too, because I never put two and two together that like the QMap stuff that I'd done would map to that stuff, but it absolutely does, and it's brilliant. I can't believe they came up with that shit. It's super smart. All right, so I'm gonna take a little break. When I come back, I'll probably do like some material shit and give my brain a rest. Later.
Shader code HLS. We have our FX as pool. That's our whole system. We'll have some controls in there that we'll go over, or the cell volume is force. So really boring. It doesn't have any movement, doesn't have any velocity. So what we'll do is under particle update, we're going to open that up. We're going to add a new model to this group. We're going to add a vortex. We're going to make like a whirlpool. So we'll add a vortex force, and we'll do this under forces here. Now you could add this under particle spawn, but then it will just add the vortex force, and then it will taper away. You'll add it when the particles get emitted, and then it'll taper off. Whereas if we add it to particle update, it's constantly going to update and constantly reapply that vortex force. So I have to make sure I place that force before the grid flip integrate particle velocity node. It has to be the before that node to be affecting the water surface. And we'll get this warning that says, it has unmet dependencies. You can see a little error there. It'll say you should add a solve forces and velocity. Don't do that. If you say fix issue, it will ruin your fluid surface. We know what we're doing. We don't want to add that because the setup is not meant to have that. If we add a solve forces and velocity, it breaks our whole simulation. Look what happens if I play. If I play it, I don't know if you saw that. We'll let that play again. I'm going to shorten my time span here. The water simulates, and then, it goes away. So you don't want the solve forces and velocity. That's for normal particles, not for a flipped fluid surface. We're already getting that calculated here in our grid 3D flip integrate particle velocity. So all we need to do is just leave it there. It'll give you that little error. You'll say dismiss. I know what I'm doing. And now what we see, if I extend my timeline here, now we start to get this vortex here. And maybe it's a bit too strong. You can see the velocity doesn't make the particles disappear. It's not killing the particles, it's trying to keep them. So if we had that solve forces and velocity, it would kind of break it, but without it, it's retaining the density at least. So for this vortex force, this is a little bit too strong, as you can see, for what it's doing to our surface here. So we're going to change this a bit, and we're going to add a fall off to it. So we have a fall off here. I'm just going to pause this for now while I make these adjustments. For the fall off, I'm going to go use influence fall off. I'm going to set it to maybe something like 250, And then for our fall off exponent, maybe 0.25. And we also need some sort of vortex amount. By default, it's just a solid value up here. What I'm going to do is change this to a random range. So it's constantly changing. So random range float. I'm going to click on this little down arrow, type random range float. And now I can choose a minimum maximum. Maybe minimum will be 15. Maximum will be 30 or 50. 50 will be a little bit better. And if you want, you can change the axis, but I think we're all good with that. And evaluation type, I'll just do every frame instead of spawn only. And now if I rewind and play, okay, so now it's starting to do this like vortex, but it's a lot more pulled back. It's not super intense. So I think this is a little bit better. I'm happy with that. So the next thing that we can maybe do is sometimes it's a bit easier to also preview the particles instead of the mesh surface here. So we can go to render and swap it back to sprite render, but I think this is okay for now. And what we're also going to do is add a curl noise. A curl noise will just add some random velocities into the surface as well. So we're going to go back here, particle update, add, we'll create a curl noise for us. Again, make sure it's before the grid 3D flip, and maybe even in this case, we'll put it before the vortex force. So it adds the noise to the water, then it adds the vortex. And again, I know what I'm doing, dismiss the issue that it warns you about here, and then we can set up these settings. So maybe noise strength, 25, frequency, maybe 8 or 10 or something, and then you can pan noise field, so the noise kind of changes shape and pans along the surface. So we'll do that, and we'll make it pan X and Y by 0.5. And if we click play, let's see what's happening. Okay, we get that curl noise, and we get the start of our vortex. So now if we want to adjust also where our vortex force is, like if I keep playing this a much longer time span, might dig into the surface quite a bit, like the water surface. Your vortex force actually has a position. So if you turn on this little eye here, you can actually preview. Take a second, there we go. You see this ball, that's where your vortex force is affecting. And we can change that positioning by changing the vortex origin offset. So on the vortex force, you have the eye enabled. You'll see the vortex shown as like this ball, and you can go and check on this vortex origin offset, and we can offset it in world space. So if I put it at like 100, it will update. Like, there we go. It updates it to move up. I can maybe make it 150, 500, so you can see where you want to place it. So you can change where it actually is. And I think in this case, we're just going to set it to maybe 100, just sitting right along the water there. And maybe we actually want a deeper water surface as well. I think our water surface is a little bit shallow. So maybe what we're going to end up doing, see a little foam and bubbles in here from that kind of turbulence. We start to see it get added at the end there, but I'm assuming that there should be more. So we can actually use our secondary emitter to add more vortex 5, 8 big is some of our particles, so they have a bit of an offset from where they were going to spawn. The offset, and it's like the size of the particle here, realism, or by default. Maybe it's a bit too extreme. We can always kind of play around with that, change it. We have ourselves a whirlpool. So the next thing we might want to do is start to add the ability of having collisions with this. The problem is right now if I have something like a sphere and I collide that into the water, maybe I'll size it up a bit. Nothing really happens. Even if I make this sphere like movable and I simulate, it doesn't really do anything to the water surface. But it's really easy to add collisions to these water surfaces. All you need to do is go on your object, if it's a static mesh, and search for your tags. So I'm going to go in here for my sphere, search tag, add an actor tag called collider, same as we did in the other kind of mini video with the smoke and fire simulation. If you add that collider tag, now when I click play, simulate, look at that. I can do all those interactive water simulations, which is really cool. Especially since it's getting turbulence applied, or like the curl noise and our vortex, I can still add collisions on top of all that stuff. So this is really cool. And it looks pretty good. There's our vortex, and we can use this ball and kind of interrupt that simulation as well. So now we start to have our actual interactive water surface. We can interact with any static mesh, just add the collider tag. So hopefully it gives you a bit of idea of how to use these flip fluid surfaces. A bit of a simple introduction and video, but it will give you a good starting point to be able to create whatever you're wanting to create for a 3D wall. In this video tutorial, we're going to take a look at how to create parallax occlusion mapping in Unreal. This will allow us to create surfaces that seem to have much more depth and detail, as seen here, but really, these surfaces are nothing more than a much more simplified mesh or a flat plane. If I take a look at the wireframe, it's really just a flat plane for this surface. So let's take a look at how we can create this effect of parallax occlusion mapping in Unreal. First, I'll start by creating a plane, and then we'll also need textures for our parallax occlusion mapping. If you're part of the Patreon, you'll get these sample textures available for download as well. But first of all, you'll need a diffuse color, so something that has the coloring of the surface. So in this case, I have this sand type texture. And then you'll also need a map that shows the height of the surface. So this is height described as lumiance or brightness at different areas of the surface. And then you'll also ideally need a normal map. And a normal map will describe the faked normal values of that surface, and this will be useful and needed to be able to have lighting to react correctly with this surface, because a lot of these shapes and details, like these footprints and dips in the sand, don't actually exist in the model. So the normal map helps fake those details by manipulating the normals, or the direction of the pixel on that surface, and that can be used to emulate lighting on these details that don't actually exist. Once you have your textures, the next thing that we'll do is have to create a material. So I'm going to go in here and right click and create a new material, and I'm just going to call it m_pom for parallax occlusion mapping. And I'm going to open up my material editor. So once we have our material editor open, we're going to have to set up the material. And Unreal already has a parallax occlusion mapping node or network that you can start to set up. So if you right click and you search parallax occlusion mapping, you'll find this node that already does most of the heavy lifting and most of the work. So it's actually quite easy to set up. The very first thing that you're going to want to do is load in your textures. So we first have to take our diffuse texture, so our color texture for our surface. So I'm going to drag and drop in my textures.
Okay, sick, 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 sick. Okay. All right. So let's see. Gonna be right back.